What if you're asked you the limit as you approach infinity of a rational expression, but it's got exponentials? So like limit as you approach infinity of, let's say, 1 over e to the x minus 5, limit as x approaches infinity of 1 over e to the x minus 5, but not infinity. Let's do negative infinity. Well, that means you have to know what the graph of e to the x looks like. It looks something like the following. That's an exponential growth curve. And if you're approaching infinity, well, then this graph is going up to infinity forever. And if you're approaching negative infinity, well, this graph is getting closer and closer to 0. So these two facts you might want to know when dealing with these types of questions. Because if I technically plugged in infinity, e to the infinite power would approach infinity, and infinity minus 5 would still be infinity, so you would get 0 for the limit as you approach infinity. As you approach negative infinity, well, we know that this will approach 0, and so you'll get negative 1/5. And these could be individual questions, or they could ask you, what are the horizontal asymptotes? And you go, oh, well, it's going to be y equals 0 and y equals negative 1/5. Yes, you can have more than one horizontal asymptote depending on what the equation is. One as you approach infinity, and one as you approach negative infinity. To do one more example here, let's say you had the limit as x approaches infinity of 2e to the x over 3e to the x plus 4, and the limit as you approach negative infinity of the same 2e to the x over 3e to the x plus 4. Now, the bottom one's nice. If you plug in a negative infinity, it approaches 0, 0 plus 4, and you get 0. The top one, though, is going to be infinity over infinity. It's an indeterminate form. It's very similar to rational functions that are like a polynomial over a polynomial, where the answer is going to be 2/3. But to show your work, you would do 1 over e to the x, 1 over e to the x, and you would get 2 over 3 plus 4 over e to the x. So when you're evaluating the limit as you approach infinity, this part goes to 0, leaving you with 2/3 and 0. And again, if you're asked for the horizontal asymptotes of the original function, if that was a function, it would be y equals 0 and y equals 2/3. So there's several examples of dealing with limits as you approach infinity when you have exponentials.